This show is brought to you by Interesting Radio. You can find all our shows over at interestingradio.nz.
We're born with a natural curiosity, and we have an open mind. We want to learn things. We want to learn how to...
And I am not a visionary. I do not have a 5-year plan. I'm an engineer, and I think
Just plug it in. It's going to say, hey, I see you plugged in a new device, and it's going to load in the appropriate drivers. You'll notice that this scanner build... Whoa.
Hey, Dan.
Hi, Mike.
No, I said, hey, Dan.
Hey.
Hey, don't squeeze the orange.
Squeezing the orange sounds like a great way to get juice all over your face.
Do you know what the phrase is from?
I know what you mean by it. I don't know where it came from.
No, I don't actually know where it came from either. But anyway, it's the thing people say to, don't run that orange light in traffic lights.
Yes. Did you use it the other night when we were flying as well?
Did I?
Yeah.
Oh.
To, not getting back too late with the sunset.
Oh, possibly. Yeah.
Yeah.
That's not where the phrase is from, though. I think I borrowed it.
Gotcha.
Yeah. Yeah, so traffic lights. I happen to know a little bit about those. So I thought that might be an interesting thing to talk about because a lot of people seem to not know anything about them.
The only thing people know is, 1, they're annoying, and 2, there's that special button that makes the lights go green for you.
There is no special button. Everyone likes to think that. We've got a great story about that, actually, where one of our technicians, he was standing at a cabinet one time and had a friend he knew from a council rocked up next to him and the lights and windows went in and says, hey, make it green for me. And this guy's standing, just 1 moment. And he pulled up because he could actually see on the screen what it was doing. So he knew it was about to go green anyway. So he's like, just 1 moment. There you go. And it went green. But it was nothing more than the lights changing on their own. So.
Yeah.
Yeah. So people know about red, ambers and greens and things like that. But there's a few misconceptions that I thought would be worth having a wee chat about.
Mm-hmm.
So yeah. Anything in particular you want to know to start off with?
I don't really know much at all. All I do know, I've learned from you, asking you annoying questions over the years.
Yeah. Well, the one thing that a lot of people probably are or are not aware of, so that's like everybody.
Yes.
It's like, in binary, there's 1-0 types of people in the world. There's people that understand binary and people that don't.
Indeed.
And then there's actually also the people that know it's in base 3. So anyway... Yeah, traffic signals are all running on 240 volts AC, so it's the same power that comes out of your wall. So actually, that yellow pole that you're standing next to, pushing the button on, there's a big cable going up inside it that's got 240 volts in it. So, but there's lots of protections in place, so it won't hurt you. But so especially if anything shorts out, it basically shuts the whole thing off, and that's why you see them off or flashing amber.
Yes.
So the flashing amber thing is actually a relatively it's kind of new, but it's kind of not. It's been a standard for a long time, but it's not used in a lot of places. Not entirely sure why. Probably because it requires extra equipment and they didn't want to pay for it at the time, whatever.
Fair enough.
Yeah, the flashing amber basically means that they're not working, treat it like a giveaway intersection. So if you ever see a flashing amber, proceed with caution because a lot of people don't know what it means and they stop and then they go and then they just blast through. So it takes time for people to learn the changes. So so they red, ambers and greens, and then the pedestrians as well, which is just reds and greens. There's no ambers there, but they run off the same outputs. So the pedestrian lights are exactly the same outputs as what the ones for the vehicles would be. So there's just no amber being shown. That's all. And the software that runs inside the box on the cabinet on the side of the road actually doesn't present an amber anyway. It just goes from straight from a green to a flashing red or whatever. So yeah, I'm kind of doing this kind of off the cuff. So there's lots of bits to it. There's a few interesting parts and how they work. So one of the other things that people think is that they are very fixed time and that they're 10 seconds for this and 20 seconds for this, or, some of them say 10 minutes. I waited for 10 minutes. It doesn't happen. So
unless you don't hit the sensor.
Yes. So all of the lights have, well, most of them, some of them don't need them or don't have them for various reasons, but there are what I call loops in the road. So you'll actually see them depending on when they were installed. If they're installed long enough ago and the road's been paved over, they're buried under that new layer of pavement. But there's slots that are cut in a couple of figure 8 diagrams, basically where you park your car at that white line. So the important part is that you park on that. And as long as you park on that, the controller knows you're there. Well, the controller's the box in the the thing in the cabinet on the side. Every intersection. And this is the worst part about being someone who does something with traffic signals, is that you can drive around any city and you just look at the traffic signals. Oh, that's wrong. That's broken. There's the cabinet. Oh yeah, that pole needs a paint. So, and like before I started doing this, you don't notice it at all. It's just red, ambers, and greens. You just drive through when you get the green light. But now that I actually work with the things, it's you begin to notice these things, and it's like, oh, that's wrong, and it's been bugging me because it's been wrong for so long. Yeah, there's one pole in Dunedin here that's got so the lights on them are called aspects. So there's like however many lights are on them. It could be 3 or 6 or 4 or 7 or 9 or they're called a 3 aspect or a 4 aspect or a 9 aspect, whatever. There's a 6 aspect on the Dunedin's one-way system heading south. I'm not going to say where, because then people will look at it and go, oh, I'm going to call in about that. But it's been hit a few times by vehicles, so it's actually quite badly damaged, and it's got funny angles in it, and I can see it, but not a lot of other people do because they don't know what they're looking for. But it bugs me. I'm looking for, it's going to get replaced soon anyway. There's a project underway at the moment which is going to get rid of it. So, well, not get rid of it, but changing. But yeah, so these sensors in the roads, they're basically a metal detector. It's just coils of wire. There's nothing terribly spectacular or special about them. They're laid in a special format, and they're at a defined length. So there's 2 figure 8s, one at the front, one at the back, and they are a defined length, and there's a defined gap between them and another defined length. So they're all 4.5 meters long, and they are configured in such a way that the controller actually knows what to expect when it's seeing the inductance change in the loop. So it knows that this particular, if you draw it on a graph, it's hard to visualize, but the inductance change, if you draw it on a graph, the controllers knows what different graph profiles mean to do with how fast vehicles are going and gaps between them and a vehicle entering and then leaving. So yeah,
I found that they mess with my AirPods.
The traffic signals.
I walk across the loops and my audio kind of breaks up.
Oh, really?
Yeah.
That's interesting. I can't see why they're white, because they're completely passive. There's no power in them at all. Other than the sensing current that's put through them for sensing, but so they're completely passive. You can touch them, nothing will happen. It's just,
because I've tested it. Like I'll walk across and it'll break up, and then I'll turn around and walk back across the road and it'll do it again.
Interesting. Yeah, that's actually quite cool.
Don't know why, unless
it's entirely possible that the frequency being measured on them, because of course they do have a frequency as well, and with the signal being measured out of them. So there is a very, very low voltage. So it's like a electronic circuit basically. Yeah. Just measuring, because there's a resistance as well for the coil, and then there's the inductance change when a vehicle goes over them. So the vehicles that you would and would not expect to set them off, the worst or the best, completely, you would not believe. Well, some people might. A car is really good. Yeah. Whereas a really big hulking hunk of metal in a big truck is no good. Huh. Do you know why? Can you think why?
Because it's too big. So
you're getting there. What's bigger about a big truck?
Further away from the sensors.
Bingo.
Up higher. Yeah.
Bigger wheels, so that the engine block is higher and it's further away. So it's harder for it to sense a big vehicle like that. It still works, but it's the best really positive on-off responses from a vehicle, a car, a low car.
Remember there was an article in the ODT sometime in the last couple of years about people moaning about being on scooters and things and sitting on the one way for 10 minutes with the lights not changing because they're not being detected.
It does happen, especially cyclists as well. There's a special format of a loop for being sitting underneath the new green stuff that's appearing, the green things. There's a special format and layout for a loop underneath those for detecting cyclists. But they're still no good for carbon fiber bikes, so you can't do anything about it. They've got no metal in them to detect, very little anyway. So, but they're a smaller loop. They've got more loops in them, so more loops, individual loops of wire. So they're much more sensitive. And being more sensitive, they're a pain because they false detect. And but it's a real balancing act to get that right. So getting it so it works perfectly every time. Well, not perfectly, but good for 95% of traffic. So
yeah, I observe people getting off and going and pushing the pedestrian crossing button for the other direction to make a change.
Yeah, and that is a reason. There's a reasonable thing to do, but I mean, quite often the design will be laid down so that certain ways of the traffic flowing will actually still work even if they're not detected. So what I mean by that is, like, you can have what's called an arterial phase. So in traffic signals parlance, there's a thing called a phase, which is basically a configuration of lights. Yeah. So one approach which is where you come up to the lights. So sorry, we got approaches. So standard 4 intersection, 4 approaches. So there's, and eastbound, northbound, southbound, westbound is usually how they're named because it's easiest to orientate yourself on the map. A given approach will be, and this is where it gets complicated as well, there's another thing called a signal group. So a signal group is effectively a given approach, a red, amber, green set, and that's what's called a signal group. So if you're at one approach, typically you'll have 3 sets of lights in that signal group. So they're all the same.
Yeah.
They're wired exactly into the same place in the box. So when they change, it's just 3 light in parallel with each other. So
okay.
There's nothing terribly spectacular about that, but that's called a signal group, a given direction. So some of those intersections you'll see with the arrows, like a red, amber, green with a little red arrow next to it. So there'll be 2 signal groups, one for the red, amber, green, and one for the arrow.
Gotcha.
So, but there's just no green and amber on that arrow. So, or you'll have ones that do have green and amber arrows, and that's just still another signal group. Pedestrians, another signal group. And signal groups get used for interesting and creative things as well. So they can be used as a way of signaling other equipment. So they don't show anywhere, but they can send a signal which can be used to flick a relay or something and do something. But anyway, so you've got these phases, which are configuration of a set number of signal groups running in a green, basically. So like a standard 4-way intersection, the most common is 2 phases for each direction on the road. So you've got giveaway rules off of the 2 approaches facing each other, and then the other ones are on red. And then that's 1 phase, and then it changes to green the other way. That's another phase.
Gotcha.
And so the phases can have all sorts of things change, and you get arrows. So you could actually have like a green light and a green arrow, which means that you've got the right of way. And so the phases. Where was I going with that? I can't remember.
The light, like bicycles and things.
So we can have what's called an arterial phase, which basically means that, well, even if there's no traffic, I'll go back to that.
Right.
Like the Dunedin one-way system is a good example because it goes back to the main arterial phase, the one-way system. However, it's also been tuned so that they still change, but they change in what's called a wave. So if you actually travel down the one-way system, it's almost perfect. There's a couple of runs between lights, which the times are just not quite right. But if you go down there at 48, 49 k's an hour, you'll get green the whole way. There's a couple of spots where it's a little bit broken, a wee bit late, a wee bit short. So
I found that railway station to Toitu going south isn't quite right because
that's pretty close, that one. But the one that you most often notice is going north before you hit Howe Street.
Right,
Howe Street will often change a second or 2 late, so just needs tuning. I haven't got around to it yet. So or I haven't got around to telling the guy that makes those changes to do it. So
it's quite. Because a lot of people don't know about that, so I tend to scare people because
you rocket towards them.
Yeah,
you've got to know that you've got to be looking for that orange.
I do.
And that's one of those things other people things do is that you're looking, you can see it's red for me, but I can see that green sort of glowing out the side for them, and it's just changed orange. Good, I'm about to get it. Yeah, but you've got to be really careful because things can cause it to change.
Yes,
so that it doesn't go in sequence. Particular traffic demands because There's the other thing I was saying is that a lot of people think that they're all timed to a number of seconds, and they're really not. Even their simplest dumb form of the box running on the side of the road on its own is dynamic. It will basically, hard to describe, but it'll wait when it sees vehicles on the loops. It'll go, I've still got time to go before I run out my maximum time for this phase, so I'll just keep it green because there's still vehicles there.
Right.
So of course, by extension, that means if you have a broken loop that's, the road surface is just destroyed from use, and it happens, wear and tear. It's just how it happens. When a loop actually breaks, so the wire in it actually is broken, there's a short open circuit in it. It's treated as a locked on or a always on connection. So that can cause the other direction to be delayed because there's no traffic there, but the loop's broken. It's a safer thing to do than have very short runs of green.
Yes.
So, but we every day. Like several times a day, the technicians are checking basically the fault list through on the central computer, and it goes, oh yeah, that's broken. We'll go out and have a look at that, fix that,
right?
Go and fix that.
Yeah.
So that's when you'll see the guys go out with the trucks and all the traffic management. It's annoying and they get in the way, and you see the saw blades cutting stuff in the road, and that's what they're doing is they're recutting the loops into the road because they've been damaged.
Yeah.
But so that's one thing. Is even if the dumb cabinet on the side of the road, it's actually got some smarts in it, so it doesn't just run a set number of seconds. They can be configured to do that. And some are for various reasons, like up the people in Auckland or even Wellington, where they've got motorways with on-ramps, and they have this thing called ramp metering, where the lights are red, and they do a really quick green, amber, red. Yeah. Green, amber, red. And the idea is that you've got one car going per green. So that's not just randomly set up. That's actually busy talking to sensors down the motorway, and it knows what the loading on the motorway is, and it's actually metering people into the motorway to keep the performance of the motorway up. And it actually works really well.
So it means that it actually gives people gaps to merge in.
That, but it also keeps the flow going so that you don't get traffic jams and stoppages. So if there's really cool, videos of explaining how it all works, and of people, with, fancy bits of road and little black dots for cars, and showing the fluid dynamics of vehicles flowing down the road, and having the ramp metering there and actually metering the vehicles into the motorway, and you can see the flow keep going with the average speeds and things. And it's quite cool. You can see people slowing down and speeding up, and it's still working. And then if you take the ramp metering away, it just completely clogs up. It's fascinating to watch, because it's all of the decisions made about how to create an intersection or how to configure it. It's not just randomly put in and then we'll see how it goes. It's actually very, very carefully analysed, and there's a whole bundle of traffic modelling done. So they work out the flow volumes of the intersection, and they work out the what types of vehicles, and then they go, well, it needs this, and it needs that, and it needs this, and it needs that, and then tunes it. So that's why when they go in, they work pretty well from the get-go, because they've been designed very carefully by traffic engineers way above my pay grade. It totally doesn't interest me, that stuff. It does interest me, but I wouldn't want to do it as a job. It's I would consider it mind-numbing. Some other people might not, but So each intersection as it's designed, and there's also fancy stuff goes on with wheel track stuff as well. So they work out what sort of vehicles are going through that are large that might need to turn. So they're working out they need this diameter to get a B train or whatever, a truck around in a bus. And so they're working out which lanes need to be cut short so that they don't actually stop right up at the line. They've been cut back. So quite often you'll see those staggered limit lines at some intersections, and they're actually there for a reason. And you really don't want to cross them, because the reason they're there is typically for a bus to get around, so that bus's nose can come around into your lane, sweep over in front of you, and get into the lane and keep going. If you pull forward too far, the bus gets stuck, just clogs up everyone behind them. Then you've got people behind you, so you can't get out of the way. You got to wait for ages for the lights to change, because the loops are all locked on because people are parked on them because they can't do anything. So park behind the white line, as I say. You really should, because it's all designed so that if people park in the right spot, it'll be efficient. If you don't, I've got another good story for that too. I personally don't like taxi drivers. I think it's a stereotyping thing, right? So I'm sure some of them are lovely, but there's definitely this. I get this feeling that they feel a little bit superior to everyone else.
They're always driving,
because they're always driving. So they're professional drivers, using air quotes there. I've come across a taxi driver once before who, at a given intersection, which was configured in such a way that the limit line is quite a long way back, the pedestrian crossing was like a long way back, and there's a big gap between the pedestrian crossing and the intersection. And he coasted straight over the top of the loop, straight over the top of the pedestrian crossing, and was parked on the far side of the pedestrian crossing, waiting for the light to change. He never got it.
Because he wasn't on the loop.
Because he wasn't on the loop. And it just kept changing to the other. And he was getting antsy. He had a passenger with him. I actually stopped and I said, look, back up behind the line. You'll get a green next time. He backed up and he got the green. He left. And that's just one of these things. If you don't park in the right spot, you're not going to get the green. So you got to make sure you park in that spot. Or you got to make sure someone is parked in that spot. So it can be frustrating when you are 3 cars back and you can see that front car hasn't gone right up to the line, because they're just like, just not too confident or whatever. So they're actually not on the loop. They're behind it. So they're still not there. So you just, move up. So there is a spot for you to be. And if you're on it, it's all good. Just another thing to mention as well is that those loops, they can be configured in many different ways. They can be like an immediate detection. So if anything triggers them at all, it's like, yep, there's someone there. I'm going to record that and I'll call that phase when it's needed.
Right.
Or it can be that they've got a delay on them. So they actually have to have a vehicle parked on them for X number of milliseconds or whatever. Right. So they could be that they have a lot of false detections, or a prime example actually is turn lanes. So quite often the turn lanes will be configured with what they call a presence delay. You've got to be on it for X number of milliseconds. Well, I say X number of milliseconds because it's not in seconds units. Right. You can do them 0.1 of a second. So you can, quite often it's set to like, 2.3 seconds or something or whatever. That again, the modelling comes into play here.
Yeah.
They decide what the appropriate time is. So if you get a vehicle coming around a corner and he's a big vehicle and he's going to turn wide and he nips over that loop, then, well, actually, I don't want it to go to that phase because it's actually not a vehicle there. It's someone turning and has nicked it coming around the other way. Or they've cut the corner and they've cut over the turn loop on the where so that's where you have a presence to delay so that you don't actually set off that phase change because of a vehicle that's cut the corner. So there's lots of little nuances and bits and pieces that come into it.
It's actually quite complicated.
It's very complicated, but all of these complications, as with all complex computer systems, as you know, they come to a fruition of a system which is supposed to be simple for the user, but does a whole lot underneath.
Yeah,
so,
absolutely.
Computer Concepts Limited has forged an enviable reputation for leading-edge ICT solutions across New Zealand. Whether your business is large or small, CCL's quality services are designed and deployed by some of New Zealand's most passionate and experienced engineers. From infrastructure to ultra-reliable connectivity, data protection and security, CCL has it covered. Visit concepts.co.nz or give the Dunedin office a call today on 470 1112.
So, well, I was talking about like a dumb cabinet. Well, I say dumb, and it's very capable on its own, but where the functionality of traffic signals really comes into play is when you link them all up with a central computer, and the central computer is busy looking at all of them. It's taking all this data in from all these intersections all at once, and it's busy adjusting things and tuning things. So you can actually have a whole corridor of signals that are all tied together in a loose sense. They're not really like dependent on each other, but the central computer will be busy adjusting the timings and the percentages of time that they each have. So this intersection had quite a high demand. So, at an intersection, you get a car that stopped and there's 15 cars behind it, and 15 cars get through and goes red. That's called a platoon. So a platoon of cars. And it's the terminology, right? Don't laugh at me. So you get this intersection that could be like the very head of a big sequence of what they call coordinated intersections. Yeah. And that platoon has arrived, and the central computer sees that and goes, right, well, I need to pre-tune all of these intersections down the line so that they all get through. Yeah. So all of that sort of tuning is done not dynamically on the fly, and it's quite clever. You can watch it do it, but you can't really sort of say exactly how it's going to do it because it's like a big black box. How these things work. You feed some input into an algorithm and it does some stuff, but you can't really directly influence it because it's dynamic and it's changing already at the back again. So yeah.
So the loops are not only counting if someone's there, but it's actually counting cars passing over it as well.
Yes and no. It can count, but it's not a reliable count.
Right.
All to do with spacing of vehicles. And
I guess it's thinking of the 15 cars.
Well, yeah, you can think of it as 15, but it might not be because people can tailgate and stuff, and it can sometimes you can't pick that up. So that's another thing as well, is that all of they end up being called detectors in the controller. So it could be from anything, it could be a push button or it could be a loop. But the loops have like different times on them as well. So you've got what's called a gap time and a waste time and a headway time. It's all to do with basically working out roughly what the biases are towards saying that's enough traffic, I'm going to cut it off now. So this comes into the efficiency thing. Yeah. So you can have 15 cars, but there might be 6 of them that are really close together, and then the last 7 no more 15 whatever the number is. I can't do maths on the fly.
9.
Leave me alone. 9, there you go. They might be spaced out like progressively longer, logarithmically or something. They could be having an extra 5 meters each, or it could grow out. So this is where these other times come into play, is that going, well, they're still meeting the gap, so they're getting there in time, but there's this other timer that's in play and it's busy counting up, working out, how much waste time there is, so between vehicles, and it's going, right, well, I've kind of expired the waste now because it means that there's been quite a large amount of open space between vehicles. That's getting inefficient. I'll cut it off and change over to the other side and let them all pull up again to get a nice compact set of traffic. So you don't always see this, but that's why sometimes you'll be going, that's the other thing, is I can drive along behind a vehicle and go, I know I'm going to be fine. I'm within the gap time here. So I know that I'm going to get around the corner or I'm going to get over through the intersection. But when I'm cruising up to that Andy Bay intersection and I'm, 15 car lengths back from the one that's just got through, I'm going, don't change, because I know that I'm fighting that waste time, and I know that there's a big gap between me and the controller's going to go, well, I've got a really big gap time here. It could be, 4 or 5 second gap time, but I've had big gaps already. So, so there's lots of dynamic stuff in play like that with the detection of vehicles and things. So.
Yeah, and then you get stuck behind someone who's texting and didn't see the light go green, and then it goes red just as they get to it.
Now, this is another thing, texting and accidents that happen. So quite often you'll have, well, not quite often, it's sort of tailed off. It comes and goes. You'll get someone calling up and complaining, it was green in both directions at the same time. I nearly had an accident. It's like, well, actually, it was red for you because it's if there's 2 people in play at an intersection and one of them had a green and one of them had a red, the one that complains had the red because they were adamant that they had the green. They don't want to be wrong. But the person who had the green won't say a word because they're idiot, can't drive.
Yeah.
But so your person that complains is usually the one that's actually in the wrong.
Yeah.
It's more often than not. But there are logs kept of how they operate, but because you imagine about the amount of data they generate, it's not kept for very long, and it's actually not useful information anyway. So every intersection has software in it that's it knows where the signal groups are logically in a virtual sort of space of the software, right? The software doesn't see a map. The software just sees a whole bundle of ones and zeros, but it knows that it's got this signal group and this signal group, and this one can go here and this one goes here. But I also know that this one is a direct conflict with that one. Yeah. So there's actually what's called a conflict matrix in every bit of software that's all carefully tested and planned out by the software designer, so that if any given green light in one direction is on at the same time as a green light in the other direction, not by the controller, but like a fault. So if a fault causes a green light to come up, the controller goes, no, conflict, that's bad. That will immediately cause accidents, so I'll shut down.
Right.
So you won't ever get a green coming up that would be in direct conflict with someone else to have an accident with you. It won't happen. It might happen for a split second, and then a controller recognizes and shuts it down. So as well as actually having a whole bundle of switching circuits inside the controller, which sends the AC signal out, 240 volts out to turn the light on and make it green or make it amber or red or whatever, it's also watching every single other one that it's connected to. So it knows that, if you've got 5 signal groups, that's 15 lamps that it needs to watch. Yeah. And it's watching all of them all the time. And it knows that if that one's green, then it should never ever be amber or red at the same time. It can only ever be one of the 3 colors. Right. So if for some reason a voltage turns up on one of the other ones and it senses, oh, there's a voltage there, that light could be on, I'll shut off. It shuts down.
So if there's a cable short or something like that.
Dead right. So, or water or a fault underground. I mean, you find that with stuff underground, it deteriorates and there's bad connections here and there and corrosion and stuff like that. Anything that's outside gets faulty like this over time. It's just one of those things. People might have seen us out and about, pulling cables through and doing things and shutting lights off and being disrupted and stuff. But what we're doing is replacing old faulty stuff, which has just gotten to the point where it's just not economical to keep going back to fix it. It's better just to spend the money to put new cable in and completely replace it. Yeah. But yes, you get this system where the controller is busy watching everything. So it's looking for a whole bundle of faults. And so there's, direct conflict faults. So green with green, or, the wrong colors are being shown, or you've got a red that you're supposed to be up, but you've got a green that's doing something. So, and the most common way that happens, if you think about it, is a neutral fault. So for people that do a bit of electrical work, they'll understand, if you have 2 things that are running off AC coming from their own circuits, but they've got a shared neutral. If for some reason that shared neutral doesn't get back to the board or get back to the supply point where the circuit's made, then the return is through the other unit. Yeah. So you end up having units going back through so especially if one of those is off, right? So if you've got your green, amber and red, and your green's on and your red's off, but then the neutral breaks that feeds those lights, then the return's actually through the other 2 lights because they've got no voltage on them. So
they're all on.
Well, you usually don't see it. Yeah. Because it's so quick that the detection of the fault happens and it shuts it down almost immediately. You've got to be looking really fast to see it. Yeah. It's crazy. I mean, it's one of the most common faults that you have when you put a new installation in and you're doing the testing. And to make sure, and that's the other thing that you'll sometimes see when the guys are out on the road working, is that if the lights are off and they're doing something weird, like they're doing a green flash and a couple of orange flashes and a couple of 3 red flashes, that's actually not them running. That's them testing them to make sure they're wired correctly. Right. So that's what's called a flash test. So they're flashing the lights to make sure that they're coming up in the correct order in the correct sequence, and they're going, yep, that's wired white, that's wired white, that's, Yeah. So, and in those tests, you can actually see it. But when you're doing that testing, the most common fault you find when things aren't right is a neutral fault somewhere. There's a neutral not connected properly, or it's there's a piece of a link missing somewhere, and manufacturing faults happen. So, but that's why they're all tested very thoroughly before they're turned on. So, yeah, that's probably one of the biggest things. There's a few things that you get faults coming through for things like that. If it was green in both directions, no, it wasn't. But we'll go and have a look anyway because you've got to go and look just in case something weird is happening.
Safety. Yeah,
that's right. One of the other ones as well is that pushing the pedestrian button once is enough.
I was going to ask you that. Doesn't make any difference?
Does make no difference whatsoever.
Yeah.
In very rare circumstances, you can have the software configured to look for certain things to go or change the behavior. Like in some installations of signals in the country, they're configured in such a way that if you hold the button down for an X number of time, it'll extend the pedestrian crossing, but it's very, very limited numbers, like special locations, for example, a crossing near a school or maybe an old person's home or something to give them a bit more time to cross. But it's one of those local knowledge things. It's this is configured so if you hold that in for 6 seconds or whatever, then it'll recognize that and make it go a bit longer for you, only by a few seconds. It's not worth playing with it to try and play with. There have been creative things done as well with when you've got a massive school classroom that's coming out of one classroom and going to the other side of the road to go and do something else. You might have it configured in such a way they've got a special way to push the button that you can't do as a end user. I'm not going to say how you can do that, but they basically have another bit of equipment which they can use, and then they can push the button in a special way, which means it holds it for a really long time, so you could get a class of 50 kids across the road all at once, rather than having to break them up, and then it causes drama because that's in the middle of the kids, and you've got to get an adult to run to the front of the line, and don't run across the road. So, but there's all sorts of really creative things you can do, and it's limited by imagination with what sort of features and functions you want to have.
This is are they radar detectors for pedestrians, right?
Yeah, so that's becoming more common. The correct industry name for it is a puffin intersection. I forget exactly what it stands for, but it's the full installation of a puffin intersection has the little green and red man is right in front of you on the pole. Yeah. So the idea is you can push the button, you can see it right there in front of you. Yeah, it's red, don't walk, green. You might not remember it, but many, many moons ago in Dunedin, there was these really big yellow boxes that are on the pole that had the button, the call button for the pedestrian crossing on it, and you push the button, and then right underneath the button is this big weight that came up in red.
I very, very vaguely remember.
Yeah, that was a really old style of button. But anyway. So and one function of a puffin intersection is that there's detection for the pedestrians above them on the poles, and they're actually cameras, believe it or not, but you can't see the picture. It's not visible to anything. It doesn't get pulled the picture off. It's doing image analysis, and it's got a picture of the ground, and it knows it's changed. The content's different, so it goes, there's something there. So what it does that for is if you push the button and walk away, it goes, it's gone back to normal. I'll just turn that off. I'll cancel that pedestrian crossing. Don't need to interrupt the traffic for that. They've walked away, or they've crossed the road already. I'll just cancel it. They don't need to do that. Yeah. Or if they wait there, it knows that if they're waiting right, I need to keep going, keep the wee red band up. But you can also, they're all configured and they're all very technical underneath and very complicated how they work. But if you actually push the button and then walk away, you'll see the red man go out. But if you walk back, it'll come back on again. And that's because there's a delay in there. It goes, right, well, they've walked away. I'll pretend that they're still there for 5 seconds. Yeah. But I'll turn the light off after 2 seconds. So if they come back within that 3 seconds after the light's gone off, I'll go, oh, they're back again. I'll turn it back on. So there's lots to it. And that's to get around people that sort of don't quite stand right on the tiles, or they're moving or whatever. So, but it's not 100% perfect. And the ones that are like this, you'll see the label on the pole that say specifically, try to indicate stand on the tiles, because they're designed and configured so that they're looking at those what they call the tactiles, the dots on the road, on the pedestrian crossing there so you should be standing there. And some of the other ones are radars in there for the crossing. So they're called on-crossing detectors, and they'll detect people moving across the crossing. So the idea is it's just biasing the green man just a little bit longer. Yeah. Or even the flashing red man, which is what they call the clearance time. Just a little bit longer, just to let them get across before they let traffic go and have green lights into people, and drivers get.
I think there's one up by Moana Pool.
Yep.
Yeah.
There's several around Dunedin.
I saw it.
The back of the railway station.
Yeah.
Moana Pool, down Georgia Street, Mosgiel. I'm sure there's some more, but I can't think of them right now. But yeah, they're finicky to set up, but once they're right, they're pretty solid. They're pretty good too.
And then you don't make drivers go crazy by having red arrows when there's no one there.
Well, not just that, but actually stopping the traffic flow because someone pushes the button and walks away, and it still makes the crossing go and nobody crosses the road. But there's no way there's nothing to stop the traffic going again except for the fact that someone pushed the button and walked away.
Yeah.
So it's twofold. It's trying to make sure that the pedestrians are looked after, but also to make sure that they're not interrupting the traffic flow too much.
Yeah, and then you have all the pedestrians that start crossing on the flashing.
So you really shouldn't do that. Like I was talking about traffic flow, and it's the same thing's done for pedestrian flow, and analysing numbers of pedestrians, and it doesn't change much, but it's generally a very standard 6 seconds for the green man and X number of seconds for the clearance or the red man time.
Yeah.
And it's designed for the average walking speed of it's 1 point something meters per second. I forget what it is.
Gotcha.
And it's designed so that that's enough time to get you started and get you to the other side with a bit of extra time to make sure you're right off the intersection before the traffic goes. So if you start walking in the flashing red man, chances are pretty high you're going to get a vehicle wanting to drive through you. So don't do that. And if you're a driver, don't squeeze the orange. So, as I was talking about before, one thing it's not illegal, but it's a fine. It's an offence, so you can get a fine for it. I'm not a lawyer, so I don't know the definitions of it, because there's certain things that are illegal and certain things that are actually not illegal, but they're an offence. So however it works, but it's not like you're going to go jail for it, but you'll get a ticket for it.
Yeah.
And its prime reason is that if you squeeze that orange, you could get hit by another car. I shouldn't say this, but there is actually a gap between the orange and the red coming on before the other green comes on. It's like 2 seconds. Yeah. People notice it anyway, but and and that's because they know that's there, is why they squeeze that orange. And this time.
Yeah.
But it bugs me because there's quite often I'll go, I really shouldn't have gone then. Whoa, there's 3 cars coming around behind me. So, and it's like, you guys really are game.
Yeah.
Crikey. And quite often for me, that's like, I know it's going to change, but it's a subjective thing, right? If you're going fast enough that it's actually dangerous to stop, but I don't know. It's different opinions, and I'd just don't go through the orange. It's
noticed that it gets pushed a lot more in Dunedin than it did in Napier.
It's crazy as well, because you get people that are talking about, Dunedin drivers are terrible. Hamilton drivers are terrible. Auckland drivers worst in the country. Wellington drivers worst. Nobody actually drives anywhere else to actually experience the other drivers. Dunedin's actually got pretty good traffic compared to the rest of the country. Yeah, there are some people that squeeze the oranges a bit, but generally they're pretty good. While we're talking about traffic, if you're actually turning into the one-way system, turn into your own lane.
Yes, please.
Please, because, the road rules actually state if there's multiple lanes, turn into your closest lane, and then you don't have to give way to anyone.
I've had a few near misses turning from the gardens to go around under the bridge.
Yeah.
Because people will come across into your lane. It's like, I just pulled into my own lane.
Yeah.
Please don't hit me.
Yeah, it's frustrating.
Yeah.
There's another place which has nothing to do with traffic signals, which bugs me as well, which is the corner from Gordon Street, I think it is, by the Big Save Furniture there, and you go around the corner to head south on Andy Bay Road. Yeah, onto Andy Bay Road there by
that one-way intersection thingy, traffic light thingy.
Yeah, that's where I think it's actually the full 4 lanes going past the BP, and then there's 2 lanes that turn in to join it, and those 2 turn lanes, one of the right-hand one will actually loop you back around the block again, so it's a pain. But the left-hand one is primed to go onto the motorway. And if you actually want to go to Andy Bay, you've got to cross across 2 lanes to get there. So people stop in that left lane. It annoys me. I can't do anything about it because there is no real solution to it.
No.
Because there's not really anything you can do. It's there's lots of solutions, but a lot of them cost a lot of money for very little gain. So, yeah.
People just need to be confident enough to get up to speed, and then they can just slot themselves in.
Correct. And move like a zip. Everyone should know that.
Yeah.
Because the same thing happens as people slow right down on on-ramps and actually nearly stop waiting for a gap in the traffic. No, speed up. You're supposed to speed up to 100k in that on-ramp and merge in.
Got your own gap.
That's right.
You're at the right speed.
That's right. That's the one. So the gap that you need to get in is a lot smaller if you actually speed up to the speed of the traffic that you're trying to join in with. So
yeah.
We shouldn't be this off topic. We're allowed to have our gripes, right? So.
Yeah. Computer Concepts Limited has forged an enviable reputation for leading-edge ICT solutions across New Zealand. Whether your business is large or small, CCL's quality services are designed and deployed by some of New Zealand's most passionate and experienced engineers. From infrastructure to ultra-reliable connectivity, data protection and security, CCL has it covered. Visit concepts.co.nz or give the Dunedin office a call today on 470 112.
What else was I going to say? Red light cameras.
Hmm.
Are they? I presume they're hooked into the.
Oh, you're talking about the cameras that are going up slowly.
Yeah, I presume they're hooked into the traffic lights, so they know when they're taking a photo of someone running red.
They're actually not for red light runners at all. They're just for monitoring.
Huh.
Yeah. So.
Because you see signs where it's like red light camera.
Oh, okay. So you're talking in general. All right. Some of the ones that are being, for those Dunedin listeners, some of the ones that are going up around the city, they're just for monitoring. They're so that the people watching the central computer and looking at the data can go, oh, that's weird. I'll pull up the camera. Oh, I see what's happening. There's actually, roadworks happening there, or oh, there's a big parade on or something. So they can, and then they go, oh, that's interesting. I wonder if I can adjust that. Oh, that's better. That's improved the efficiency. So there are guys that are always looking and actually tweaking and adjusting things as they need to. So it's not just stuff out on the street that nobody's looking at. They're basically looked at and maintained every day, non-stop by people. So but anyway, the red light cameras, I actually know very little about them.
Right.
I have never dealt with them. I've never seen them. Other than the fact that they exist. But I suspect they will be hooked into lights somehow. But
yeah, because there's that backwards facing orange on the one way as well.
Oh, should I talk about that?
I don't want to get you in trouble.
No. No. It's actually interesting. There was a windy incident a couple of years back, and as does happen in the wind, I mean, these, like the mast arms you see hanging out over the road, they will sway a bit in the wind.
Yes.
And they're not actually like totally rigid.
Right.
So they're designed back at the pole. They're actually designed with a shear bolt, so that if a big tall vehicle actually hits them, rather than actually bending stuff and breaking things, whatever, it'll actually just swing it around. It'll just break the shear bolt and it'll swing around on the pole. But, if things break from other reasons, or the bolt falls off, or the nut falls off, or something like that, it happens. It's, vibration's incredible. Like the faults you get from vibration, just from vehicles driving past things.
Wow.
Connectors falling out, and all of the connectors inside the controller cabinet are all like positively retained with clips. For this very reason, is that they do fall out, but the clips break sometimes, and it's like, well, it's actually kind of hard to replace that cable. It's all wired in, so you just sort of, it'll be okay. And usually they are, but just sometimes that you'll have an issue and then you'll eventually get into replacing it. But so vibrations is, it does loosen things. So you'll actually find that some of the nuts that hold the nuts and bolts that hold things on can come loose and they can swing around in the wind. Anyway, what I was getting to with wind was this windy incident, and it happened to be at the time we were doing some work on that intersection with that funny horizontal backwards facing light on the one-way system. And someone from the paper rocked up and asked and sort of said, oh, fixing and stuff on the wind. Yep. And they took a picture thinking that was the one that, it's intentionally that way.
Yeah.
Yeah. It was an experiment. What it's actually for is the other way. I really shouldn't talk about
it. Don't if you should talk about it.
No, it's fine. It's tied into a couple of loops in the pedestrian crossing on the other side. They're actually not for the vehicle detection, but they're actually for presence detection. So if you actually run over those loops during the amber, the light will come on the other side. And they're lined up in such a way so that one for each lane, so they know which lane it is that ran the amber.
Gotcha.
And the one in the middle is the amber. It's just tied into the same amber, so that whoever in a car with some letters on the side and lights on the top is parked down there, they can actually go, oh, amber, so I know it's gone to amber, and that one's on, right, I'll pull them over. They've run their amber. I don't actually know if they've used it, but it was a trial put in many, many, many years ago, but it's still there and it still works. So,
So I was going to ask if the other two lights actually did anything, because I've never seen.
They do, but people are actually pretty good.
Yeah.
And some people do, but there are certain places where they don't, which is really interesting. Believe it or not, that intersection that we're talking about, some people know where it is. It's, well, at least a few years ago when talking about it with the appropriate people, it was the busiest intersection in Dunedin, believe it or not, coming off the overbridge there.
Yeah.
So you wouldn't think it is, but just due to the volume of traffic that sort of comes in and meets at that point, coming from Portsmouth Drive and coming from south. And it's quite busy.
I don't like the 5-way intersection just up from it, especially when I'm driving home.
Yeah. That's the other thing you do when you're working on traffic signals is you learn the phasing. You know what's next. I mean, people that drive through them regularly learn as well.
Yeah,
but,
I have.
But when I know because I know the drawing for it and I go, oh, yeah, no, that one's next. I just have to wait another 30 seconds or whatever and it's me. But it's like the certain times that I'll be sitting there, I really shouldn't. I'll start creeping because I know that I'm about to go and then I'll, shouldn't do it. But you can't help yourself. Yeah, so the 5-way ones are hard.
Yeah.
They actually work really well as roundabouts. But, and people love or hate roundabouts.
Yeah.
The one, depending on where they are, like the roundabout that comes off the motorway into Mosgiel is diabolical just because at the wrong time of day you got traffic coming from multiple directions trying to get through it and it blocks the one high volume stream, blocks another high volume stream and there's not really a break up to them. But in certain other places like those 5-ways it works quite well, but they really don't service pedestrians very well at all because you can't cross near them. If you cross near them, you're high likelihood of getting hit. So
the traffic lights go on.
Traffic lights serve pedestrians much better. And and a lot of the little red arrows appearing and things like that, they're called pedestrian protection arrows. And yes, it's for the idea is that, you know, if the pedestrian crossing is running, you can go straight through on the lights, but the wee red arrow will stay on to stop you turning into the pedestrians. And there's a big push to look after those pedestrians. I mean, you know, it's the person that's going to come off worst in a vehicle.
Oh, absolutely. So, drivers are impatient.
Oh, are they what? So am I. So are we all. Yeah.
Yeah. For some reason, people really push it, that one, because I come, down past Spates and around to head towards South Dunedin, and that particular green doesn't last very long at 5 o'clock. And, I'll go through just as it turns orange, and there'll be 5 or 6 cars behind me that go through as well.
Yeah. It's crazy. It's funny actually because you can actually end up being stopped at a set of lights somewhere and you go, oh yeah, that guy blasted through the orange. It's all right. I'll meet him at the next intersection. And you do because he's been caught up by the next one. And that's the one thing about going through the one-way system. There's no point in rushing it because you'll just get caught at the next one. They change in sequence and if you've basically got to,
that 5-way is so wide that even if you catch the start of the orange, it's still red before you get to the other side.
Yeah.
Which is, so if you go through at the end of the orange, it's most definitely red.
Yeah, it's hard. And that, like I was talking before about the dynamic intersections, that's the reason that's gone like that is because it's low demand at that time of day. Well, I don't know exactly. I'm assuming that's probably why. But so you can have set timings for phases or you can have different configurations. And one form of a configuration is where instead of having fixed timings, you actually have a cycle time. So you have X number of seconds, and that grows and shrinks based on demand during the day, or what they call degree of saturation. Right. More terminology and techie words. But the higher the saturation is, the more cycle time is added up to a peak. You can't go past a certain value; it becomes really inefficient. Right. But the idea is that you think of it as a pie graph, and each phase is given a percentage of the pie, and it adjusts. So you get X number of seconds in that cycle time to do what you need to do. But if you're on a particular approach or a part of an approach, which is part of a phase which is getting low demand, it gets a really low time in that cycle time because it's if there's only 2 or 3 cars, well, inconvenience them because we're saving the 50 or 60 that are trying to get through the main road. And it's annoying, yes, but it swings and roundabouts, but there's constant tuning happening, so that especially when new stuff goes in as well. The easier that you have to remember that when new stuff goes in, it's always going to be tuned. It'll be pretty good, but it'll get much better over time as the boffins play with their numbers and do their twiddling and make it better.
So is that stuff based on time, or is it have they done statistical analysis to say, well, this one's going to be busy at this time, or is it based on sensors or both?
Sensors. It's all based on the saturation,
right?
Based on what the controller's detected through the loops. So those loops are really integral to running the intersections. So
for example, if it was a public holiday on a Monday and it's not so busy at 5 o'clock, the lights will be completely different.
Yeah, it's entirely dependent on the time of day, the amount of volume.
Yeah.
One set of lights will operate completely differently if the road on one side is closed, or if
Gotcha.
Or if like a whole thoroughfare is closed, it just will behave completely differently. And it's all just to do with demand on different approaches and different,
And that's a combination of central computer and local decisions.
Yep. And they can be configured so that they're only operating locally, and the central computer connection is just for monitoring, just for faults.
Right.
But more often than not, they're actually linked up with another set somewhere. So like the one-way system, or any one-way system where you've got a set of lights down a thoroughfare, they're really easy to coordinate because all traffic goes one direction.
Yeah.
So if you think about it, there are other corridors that are coordinated, but they're for both directions. That's really hard because you can tune it for one direction, but it completely screws people going the other way.
Yeah.
So there's real, careful, finicky balancing acts that happen to try and make that right. And yes, the central computer system does have, time and schedules and stuff, and it goes, well, it's now in rush hour here. We're expecting most of the volume to go that way, and this time we're expecting most of it to go that way, into and out of town or whatever. Sure. So there are, basically setting a sort of like a flag that says, hey, bias it that way. Bias it that way. It's not like a hard make it this or make it that, but it's more like a, weight it differently.
It adds that into the calculations.
Yep. And we did touch on inputs a little bit, so the detectors and buttons and things, but you can have inputs from other things. The prime example is railway lines, so you can have traffic signals near railway lines, and the signals will actually be tied in. They'll know when the train's coming.
Yeah, goes red and stays red.
Yeah. So the one that works absolutely the 100% the best on that is down on Anzac Ave.
Yeah.
And when that barrier comes down, you basically can't get across.
Yeah.
Sorry, but there's nowhere for you to go. It's safer just to make people wait.
Yeah, because otherwise people will pile up.
Yeah, well, the biggest thing is the trains are incredibly unsafe, right? They can't stop.
No.
Then having spoken to an acquaintance who I know outside of work with trains, he's a train driver. He says it's just crazy the number of people that do silly things in front of him. He just has to close his eyes and just hope that they move, because you can't do anything.
Can't do anything about it, yeah.
Don't play with trains. They're really dangerous. Incredibly efficient vehicles of travel.
Yes.
Like, a little bit of diversion here, but for each given carriage,
the surface
area touching the rails is like less than a 50-cent piece. It's crazy small. It's solid wheel tires on solid steel track. Oh, sorry, solid steel on wheels on solid steel tracks, not tires. Yeah, there's just a tiny little spot underneath that's actually touching.
Amazing that they have enough traction.
Yeah, they're all electric. All trains are electric. Well, actually, apart from steam trains, but the diesel ones are electric. Only the reason the steam ones work is because they use the pressure of those steam cylinders and stuff. But you can't drive a gearbox slow enough to get a train. You'd have thousands of gears to get through. So you use electric. So the diesel engines drive a generator which drives power to the traction engines on the wheels, and
because it has to move that slowly to actually keep grip.
You need that electric 100% torque at 0 RPM to actually get it moving. So it's there's another person I know of who is related to these. Says the people in train enthusiasts are called foamers because they foam at the mouth. But I'm not one of those, but I do quite like the technology. It's fascinating. Like the total distraction here. Sorry, but they're kind of related. They pass through some intersections. The flanges on the sides of the wheels. Yeah, they don't touch the rails. They're actually not supposed to. That's just a safety feature,
so that it doesn't fall off the rails.
Correct. Yeah. So if you actually draw a line, it's actually an arc between the flat surfaces of the train's wheels. It's like a semicircle, or it's an arc. So the train's actually sitting on. If you continued that arc through both sets of wheels and whatever, you'd have this basically like a ball that's rolling down the track.
Wow.
And it's two little slivers of that. That's
and that's what keeps it centered on the rail as well.
It balances in that the weight going through. It's crazy. So those flanges on the wheels are just to basically stop it falling off on corners where it sort of pushes out a wee bit, and that's why you get the squeaking. So because that's the flanges hitting going around corners and stuff. It's a distraction.
Right.
Well, there you go. That's a little rundown on a little bit on how traffic signals work.
That's pretty well done for off the top of your head.
Yeah, I mean, there's a lot to them, but there's a few little simple things like that they're very dynamic. They actually operate by analyzing traffic volumes and flows, and they're designed for given installation is not just plonk down and install it and saying, "I'll put an arrow here" or whatever. The guys, the boffins, spend some time and work out what the best option is, and say we need some turn arrows for this because that's lots of people turning there, or we need to stop this, or we're going to put overheads in here because the volume is high enough that we need people further back to see it. They go far, all those sorts of things come into play.
Was there, just sort of one more question, just before we wrap it up, was there a lot of work when the giveaway rules changed?
Nah.
Arrows and stuff having to be changed?
Not really.
No?
There's a few little bits here and there.
Yeah, because I noticed a few, extra arrows that went in and things like that.
Some of those are probably unrelated. Yeah, there wasn't a lot to change.
Okay.
It's fortunately the way that most of them run, it's kind of, a little bit irrelevant really what the giveaway rules are, to be honest. So, yeah. But, and there's those people that still don't know the new giveaway rule. It's been in, how long's it been in now? Been 3 years or something, 4 years or something?
3 or 4 years, yeah.
Yeah. Anyway. All right, I think they'll probably have to consider that the end of the show. But, yeah. Until next time.
Yeah, thanks, Mike.
What are we going to talk about next time, do you know?
I think we're hoping to talk about power generation if we get Renee on.
Let's get Renee back.
Yeah.
Well, actually, he wasn't on this one. He's on the other one. But
He was.
He was. Anyway, folks,
Right,
next
good.
time. Yep.